Hello. I wanted to give a brief overview of two main topics that we're going to be talking about quite a bit in the coming weeks. And these two topics are slope of a line as well as area under a curve. Being able to calculate these will be very important when we're talking about position, velocity, and acceleration curves. So let's start out with slope. So the slope of a line is basically a measure of how much the line is angled, anywhere from vertical to horizontal. And so we calculate slope as rise over run. So basically what that means is how far a line changes in the vertical axis divided by how far it changes in the horizontal axis. So, for an example, we're going to talk about this line right here. So the way to calculate slope is to choose 2 points on this line. I'm going to choose the point here. I'm going to choose the point here, which is 1, 3. And I'm also going to choose the point here, which is 3, 1. So the way that we calculate the slope between these 2 points is, as we have written over here, rise over run. So let's first look at rise. So the slope between those 2 points is going to be equal to the rise. So if we look at this point, so we're going from this point to that point. How far does the line rise as it goes that way? Well, the answer is 2. It goes 2 units. That is the change. But remember, it is downwards. And so we consider a downwards difference to be negative. So our rise would be -2, because from that point to that point, it goes down 2 steps. Now, our run is our horizontal change. So our horizontal change from that point to that point, is again 2. But since we are going from left to right, it is positive. So our slope for this line is -2 over 2, which is the same thing as -1. So the slope between those 2 points of the line is -1. One interesting note with a straight line is that if you were to choose any 2 points on this line, the slope would be the same. That is true for all straight lines. So let's look at this a slightly different way. Instead of counting the change on the grid marks, we can actually input the coordinates of the points into this formula. So the way that we calculate that is the same way. We do rise over run, but instead of counting out the increments that it rises, we input the coordinates. So rise, again, means the change on the vertical axis. So that is going to be the change of the y coordinate, which is the second number here. So the way that we calculate change is by taking the second number and subtracting the first number from it. So the change in our y coordinate, or the rise, would be 1 minus 3, because it is the second coordinate minus the first coordinate. So we have 1 minus 3 as our rise, and then our run, we do the same thing, but we use the x coordinate this time. So we do 3 minus 1. And as you see, if we simplify this, we get -2 over 2, or -1. It gives us the same answer, whichever way we do this. So that is a generic introduction to slope. On a straight line, which are going to be most of the velocity graphs that you're going to see, the slope is going to be a straight line. However, if you're looking at position graphs, you might have a parabola. And the way that you calculate the slope on a parabola is a little bit different and involves calculus. So we are not going to ask you to do that in this class. but you should be able to tell us the slope of a straight line. So now we're going to talk about the other concept, and that is area under a curve. So the term area under a curve is a little bit misleading because it's not always under the line. Area under a curve basically means the space between the line that we have graphed and the x-axis. So what exactly is this area? So if you were asked to find the area of the curve at, let's say, time t equals 2, so that's this x-coordinate on our velocity time graph, we're asked to find the area under the curve at this point here. The way we do that is we take this point, we draw a line straight downwards, and then we figure out the area of this shape here, from 0 to 2, between this diagonal line and the x-axis. So the area that we're trying to find here is this shaded area. So I'm going to shade in all of these squares here, as well as the little triangles. So this shaded green area is the area under the curve at the point, or at the time t equals 2. And the y-coordinate for that is also 2. So what is the area under the curve here? Well, our unit squares they all have an area of 1, so what we can do is count the whole unit squares. 1, 2, 3, 4, 5. And then we add the 2 half squares. We have 2 triangles here, which make another square. So between them, we have 6. So our total area is equal to the squares plus the triangles, which is equal to 6. So that is how you find the area under a curve. However, remember, it is the space between the line and the x-axis. So let's say we wanted to find the area of the curve at this point here. And I'm saying at this point, but in this context, what that means is between 0 and that point. So this point right here is 1, 2, 3, 4, 5 is the x-coordinate, and the y-coordinate is -1. So if we wanted to find the area of that, we'd take the area from here all the way to here. So that's pretty simple. We can shade in these squares and these triangles. But then we run into something interesting here. The line crosses the x-axis. So what we have to do is remember, the area under a curve is the space between the line and the x-axis. So we shade in the region here, and it's technically above the curve, but it is between the curve and the x-axis. But there's one interesting thing that you have to note here. Notice I colored it in red. Area under the x-axis is considered negative. Normally you can't have a negative area, but in this case you can. So the way you would calculate this area is similar to the way we did last time, with one difference. So we can start off by counting our green squares. 1, 2, 3, 4, 5, 6 whole green squares, plus we have 2 triangles and 2 more triangles. So we have 7 and then 8. So the total green area is 8. But then we also have this red area here. This red area has area 1/2. So because this area is below the x-axis, we have to subtract it. So our second area calculation is going to be our green area, which is 8, minus our red area, which is 1/2. So our total area in this case is going to be 7.5. So that is how you find the area under a curve as well as the slope of a line. So why are these important? As we mentioned in class, the slope of a position graph is the velocity. and the slope of a velocity graph is the acceleration. And similarly, the area under the curve of an acceleration graph is the same thing as velocity, and the area under a velocity curve is the same thing as position. So these are all related through calculus, but you don't need to know that for this class. So just being able to calculate slope of a straight line as well as area under a curve of a straight line will be all you need to know for this. So thank you very much, and I hope that helped.